Welcome back to another video. In today's video, guys, we are going to be having a look at the computer science May June 2022 paper that was just done just a few months ago. So this is the latest paper for the computer science syllabus so far. So let's begin with this paper, and without wasting any time, let's just start with the paper. Okay, so first question looks like it is on the MP3. You don't even need to read everything. It just talks about MP3. First of all, MP3 uses what? MP3 is a sound file. You don't even need to know CS to know this, right? MP3 is a sound file. A video file would be MP4. An image would be .png, for example, .jpeg. There's a lot, right? So for a sound, that shall be MP3. That is the answer. So straightforward. Okay, tick to show whether the MP3 file is lossy, compressed, or lossless. Now, if you have read your notes, you know that an MP3 is lossy and lossless. What's the difference between lossy and lossless? Now, lossy compression, the data is lost. Here, not lost. Okay, it's as simple as that. So the data is lost in one and the data is not lost in the other one. Okay, so the difference between the lossy and the lossless is the fact that one data cannot be retrieved back, which is the lossy, and you can retrieve data back in the lossless. So that is the difference between the two. And MP3 is a lossy, which basically it finds repeated units and then removes them, and it uses something called the RLE. Okay, which you don't need to know for IGCSE, but sometimes they give you a mark for mentioning RLE if they tell you to explain lossy. So yeah, RLE. So for an MP3 it uses lossy compression. Pretty simple. The next question, it looks like it's talking about the von Neumann model for a computer program. The von Neumann model for a computer system, we talk about the buses and so on, stuff like that, the CIR, MDR, PC, all that, fetch, execute. That is what the von Neumann model simply means. Now, the computer has a CPU. We know what a CPU is, just the main unit of the von Neumann model, and data is fetched from the primary storage. And now examples of primary storage is RAM and RAM and ROM. You need to know the difference between these two. RAM volatile, ROM non-volatile. Okay, so data is fetched from the primary storage into the CPU to be processed. I'm giving a lot of information that is not necessary, but that is the reason for the revision. You know, the more information that you get to know from a certain type of question, the better for you. Okay, that's the reason why I'm actually giving a lot of explanations, even irrelevant that it may sound. Okay, so it says state the name of the primary storage where data is fetched. Where data is fetched, we call it a RAM. Okay, now ROM only stores up boot up instructions. It stores up stuff for the operating system. Okay, so if you want to fetch it, you will have to fetch it from that RAM. Okay, the RAM is where it fetches because we are currently processing it, so that would be RAM. Now the CPU performs a cycle to process data, and they've told us fetch is the next one. What is the other one? It's fetch, decode, execute. So decode and then execute. So fetch, decode, and then execute. That's just the structure. You just need to know that. Identify two components within the CPU that uses this. Now you can just give any types of buses that you need. So here you would just say MAR. The full form of MAR means memory address register. You could even say PC, which means program counter. You can say any of the buses like address bus, data bus, control bus. All of that will be correct because they are components of the CPU. So that should be correct. Now, let's move on to the next question. Three types of storage media are magnetic, optical, and solid state. Okay. One example of a solid state storage is the SSD. Identify one other example of a solid state storage. Now, we have something called the SD card. An SD card is a solid state storage, and also the one that we usually know that comes in our notes a lot is the USB flash memory drive, or you can just write USB. Which comes out a lot. Now you need to understand how solid state drives work. They use something called NAND technology. They use transistors, all that. Okay, read write arms and all that type of stuff, right? So that is what solid state drive is. That is what that is an example of solid state storage. Okay, the next question, it says an optical storage. So an optical storage uses a laser, so it's using a laser to store and read data from a disk. Okay, so it's using a disk. Explain how the laser is used to store and read data from a disk. So the keyword here, okay, is disk. Okay, disk is the keyword. Disk could be either CD, DVD, you know, all that type of stuff, Blu-ray. So you would explain all this. Okay, now to explain this, any question that involves a disk, you must mention laser is shown onto the disk. Okay, laser is shown onto the disk. The next thing you need to know is that there is an arm or a head that moves this laser across the surface of the disk. So arm moves across the disk. The next thing you would say is that this laser will burn bits onto the surface of the disk. So laser burns bits onto the surface, okay, onto the surface of the disk, okay. The next thing you can say is that laser is used to read the bits and lands. Now CDs, right, a disk or anything, they use something we called technologies as pits and dumps. Okay, they're called pits and sorry, made a mistake here. Pits and lands. Pits and lands. Pits and lands are simply different surfaces on the CD that reflect different amounts of light, and that's how the microprocessor or a sensor will be able to capture what is on that disk, and that's how a disk works. And that's the reason why a disk rotates in circles. It has to capture all the, you know, segments of it. Okay, so that is what we need to explain there. Okay, so hopefully that is 3 marks. I've explained a lot verbally, haven't written it, so that is how it is. You know, everyone can just see the marking scheme. The more important thing right now is to understand all the concepts of the question, to understand the question. Next question. Okay, a business is creating a new mobile device that has an SSD as a storage, as a secondary storage. Give 3 reasons why. Okay, give 3 reasons why an SSD is the most suitable secondary storage for their mobile device. For their mobile device. Now, if it's a mobile device, you need to give relevant information. If it's a mobile device, first of all, it is small in size. Now, usually, whenever we are talking about SSDs, they usually compare it to something called HDDs. HDDs are robust, they are old, they consume a lot of power. So here you would say low power consumption. And another thing you would say is that it runs quietly. Okay, it runs quietly. That would be your 3 reasons why. You could also say that it is robust when dropped. HDDs are also robust, but this is more robust. It also has fast access, fast read-write speed, so on and so forth. Now, identify 2 examples of softwares that can be stored on the SSD. Now, here you would mention any of any software that involves SSDs. So, any type of application, for example, Paint. Now, this is just a random example, Paint, but this is simply in brackets an application. This is an application. Okay, Paint is an application. And also, another example of a software would be the operating software, the operating system. Any function of the operating system will be valid. So a good answer would be operating system. Okay, the next question. All data needs to be converted to binary data. So all data needs to be converted to binary data so that it can be processed by a computer. Explain why a computer only processes binary data. Why does a computer only process binary data? The first thing you need to know is that if we read chapter 1 of the textbook, we basically related the idea of binary with 1 and 0. Sorry, we related binary with the computer with the helps of 1s and 0s, okay? Because computers consist of logic gates, logic circuits. And in logic circuits, we know we use the mnemonics 1 and 0, logic circuits, and can only process 1 and 0, which would be on and off, isn't it? It would only process the on and off. That's the reason why we write logic gates. So that's very straightforward. The denier values 64, 101, 242. So we got these ones. Oops. We got these ones. So 64, 101, 242 are converted to 8-bit binary values. Give the 8-bit binary values of each of the denary. Okay, so we need to get the binary values. Best way to do this. I'm gonna write this method: 1, 2, 4, 8, 16, 32, 64, 128. Okay, so let's start off with 64. We need to make 64 with these values. So 0, 1, 0, 0, 0, 0, 0, 0. That's the first one. So the first one is 0, 1, 0, 0. So that's 2 zeros and then 4 zeros. 1, 2, 3, 4. We go with 101, 101. So here's going to be a 0. Here's 1. What's 64 plus 32? 696. So we'll need this 1 here. Now we need how much more? We need 5 more. So this is 0, 0, 1, 0, 1. Okay. What I'm simply doing is just adding it up. Adding all these numbers to make 101. So the next answer is simply... okay. And then the next one is 242. 242, we will need, I think, 8-bit binary. So we cannot exceed that. So 128 plus 64 is 12, 390, 192. So we'll need this. What is this plus this? So 4, 12 to 24. So we'll also need this. How much do we have left? Plus 16, let's see. 10, 3, 4, 240. We will also need this. And then these are just like that. So it's as simple as that. So 1, 1, 1, 1, 0, 0, 1, 0. Okay, there you go. Let me just quickly erase this. Okay. So yeah, that's how you do it. Pretty simple. I like to use this method. This is the method I prefer. This is the one you just write this and then you write the values right here and then you can get your answer. Pretty simple like that. Okay. Move on to the next question. Next question says the hexadecimal values 42 and CE are converted to binary. So this is converted to binary. Give the binary value for each of the hexadecimals. So how do I like to do this? I need to give the binary value. So what I do is split into 2 parts. Write 1, 2, 4, 8. 1, 2, 4, 8, and I need to make 2 here, so it's going to be 0, 1, 0, 0, and then I need to make 4 here, so 0, 0, 1, 0. So that is the answer. Okay, we go to CE. If I want to make okay, if I want to make CE, now A is 10, B is 11, C is 12, D is 13, E is 14, F is 15, isn't it? So if I want to make E, which is 14, that's going to be 8 plus 4 plus 2, so 0, 1, 1, 1. And then if I want to make C, which is just 12, I'm going to make 8 plus 4, so 0, 0, 1, 1. So the answer is that. Let me just confirm. 8 plus 4 is 12, plus 2 is 14, yeah. So that is the answers to that question. You get your easy 4 marks there. Easy 4 marks. Let's move on to the next question. So the next question says an image is stored on a computer. The image is 16-bit. Look at this. It is a 16-bit. You gotta see that. It is a 16-bit color and it's 100 pixels high and 150 pixels wide. And I have to calculate in bytes. Now, so if I just firstly do 100 times 150, this will give me the amount of pixels. So that's going to be 15 and then 3 zeros, so 15,000 pixels. So that's how many pixels I have. Now this 15,000 pixels is a 16-bit color. So if I want the number of bits, I will just multiply it by 16. Okay, I will just multiply it by 16. Okay, so what is 15 times 16? Let's see, 0, 3, 6, 9, 5. Have I done that right? 6, 0, 3, 6, 9, yeah, 5, 1. 1 plus 0. 9 plus 5 is what? 14. So 240. Right, 240. So 240 and then the 3 zeros. So that is how many bits there are. Okay, that is how many bits there are. Now I want the number of bytes. 1 byte is 8 bits. So if I want the number of bytes, then I want to just divide this by 8. So that's going to be 30,000 if I'm not wrong. Yeah, 30,000. So that is the answer. It's right here. Oops. Right here's the answer. This is the answer. Okay. Number 6, a compiler and an interpreter are two different types of translators. One similarity between a compiler and an interpreter is that they both translate high-level language into machine code. Give one similarity between a compiler and an interpreter. One good similarity is they actually both check for errors. They both check for errors. Simple, nice, easy one, not complicated. Example, two differences between the two is there are a couple of them. Now a compiler creates an exe file, okay. Interpreter does not. The next reason you could say is that interpreter translates line by line. We all know this, like Python, while compiler translates entire program in one go. Okay, and then creates the entire errors. Adele chooses to set a biometric password for her mobile device instead of a PIN. State what is meant by a biometric password. Biometric password is just simply using your body parts to set a password. So you're using biological data, or another thing you could say is that you are using features of humans to store data. Okay, so that's pretty easy. Give two reasons why a biometric password is more secure than a PIN. First of all, you cannot guess this. Cannot be guessed. Okay, with the other passwords you can guess, but with a a body part you can't guess that, of course. And then I'm going to avoid saying you, and I'll say it is difficult to replicate / fake biometric password. Okay, it's difficult to replicate the biometric password. Okay, let's move on to the next one. Adele has a software-based firewall installed on her mobile device. The firewall gathers data about the traffic coming into and going out to. So that's what so it's going into and out to of her mobile device. That's what a firewall does. We all know how a firewall works. Explain how the firewall uses the gathered data to keep the mobile device more secure. Okay, we want to make it more secure. So first of all, this data is compared. The data is compared to set criteria. Okay, it's criteria set by user. So you can just even write here set by user. If the criteria doesn't meet, if the traffic doesn't meet criteria, rejected. So if criteria not met, then blacklisted, I think is what we call it, blacklisted, or we would say blocked. Okay, and this will prevent hackers. Okay, and that's why it makes it secure. You have to just always answer the question. Okay, this will prevent workers and alert. What's her name? Adele. Yeah, alert. Adele, right. Adele also encrypts the data on her mobile device to keep it more secure. State how encryption will keep the data. So now basically it'll just scramble the data. So scrambles data and makes it meaningless. Makes it just meaningless. Okay, finally, now got one of the always coming topics, which is logic circuits. Let's have a look at this. Let's first of all study the logic circuit here. So if I look at this, let's see, let's put yellow. Okay, whatever. Now, if I study this, first of all, we have an A not B. I'm going to put this in different colors. Let's have a A not B that is together. We have a B nor C that is also together. This is some complicated. Okay, there you go, finally. Okay, then we have the AND C, and then, okay, wait, before that we have B nor C, and then we have not B nor C. So this is linked with this. Look at the brackets, guys. Look at the brackets. Now, to make it more understandable, I'm going to look at the brackets. So we have first bracket here. Then we have this bracket that is in here, and a bigger bracket that is in here. Then we have a bigger bracket that will cover this, and then finally the entire biggest bracket. That is how it works. Okay, so we are going to do it in the order of brackets. Always do it in the order of brackets. So this is the first order, so we're going to do the first one. So let's do the first order. Okay, this is blue, isn't it? Let's get black back. Okay, so let's do it in terms of order. So the first one is A and not B. A and not B. So let's try to draw that. A and not B. I'm gonna excuse me for my terrible drawing, but I'm gonna try this. And then it's joined with an AND gate. Wow, that is a really bad AND gate. So it's joined with an AND gate. Okay. So we've done the first one. Let's do the next one. B nor C. So let's do that. B nor C. Nor is like that with a circle. So B nor C. And then this is not, because of this. So we've done that. Now this is both connected with an OR gate. So it is connected with an OR gate. And then finally it is connected with and C. So there you go, that's done. Done. Okay, let's do the working space. First of all, what I like to do is label everything. So label 1, 2, 3, 4, 5, and 6. So we have 6 of them. So 1, 2, 3, 4, 5, and 6. Okay, let's start off with 1. 1 is what? 1 is the AND gate of 2 and A. So actually, let's start with 2. What's 2? So I'm gonna make this the first one. This one. Okay. It doesn't matter your order, but I just feel like starting like that. So it's not B, so let's do not B first. So 1, 1, 0, 0, 1, 1, 0, 0. Let's go with number 2. 2 is the combination of A and 1, and it's AND gate. A and 1, AND gate. Okay. And then 3 is the NOR of B and C, is it? Let me just check here. B and C, yeah, NOR. B and C, NOR. I'm going to first do it here. B and C, NOR. So addition is this. So the opposite of that. So 1, 0, 0, 0, 1, 0, 0, 0. Let's just quickly erase this. I first usually like doing OR and then flip it. That's what I usually do. That's what I did there. 4 is opposite of 3. Okay, so that basically just cancels the effect of the NOR. But okay. And then it joins with 2 and 4 to form an OR gate. 2 and 4 to form an OR gate. And then finally 6 is an AND gate with 5 and C. So 5 and C AND gate. So 0, 1, 0, 1, 0, 1, 0, 1. So that's the answer. 01010101. Nice answer. Right, 0101. Okay, let's move on to the last question. Or is this the last question? No, two more questions. 3 questions. Okay, 3 internet terms are browser, internet protocol. So we have a browser, we have an internet protocol, and an IP address, and the URL. 5 statements are given about the internet terms, and we are supposed to take them. It contains a domain name. Now, URL contains a domain name. It's only URL. Browser doesn't have a domain name. IP address doesn't have a domain name. And when you buy a domain name, it's for the URL. Domain names are for websites. URLs are for websites. It is a type of software. Only browser is a type of software. Browser manages the cookies. Browser does this. Browser does that. It's a type of software. Uses HTML only a browser. Okay, because when you want to make a website, which is a browser, you use HTML to display it. Browsers display stuff. IP address don't display anything. URLs, they don't display anything. They're just the address of the browser. Is a type of address. I said type of address. Both of these addresses. URL is the address of a browser. Okay, it stores cookies. Only browsers store cookies. As I said previously, it is a software. It stores cookies, so on and so forth. So that makes that the answer. 3 features of a MAC address. Simple, very simple. First of all, unique address. Always mention this. Then assigned by manufacturer. Assigned by manufacturer. And then feature 3, you could say, let's see. Can be used to identify. Can be used to identify a device. Okay, simple, man. Simple. The paragraph describes the process of printing a document using an inkjet printer. So we are talking about an inkjet printer. Complete the paragraph using the most appropriate terms from the list. Not all the terms in the list will be used. Data is sent from the computer to the printer. The data is held in a computer, in a print buffer. Okay, a buffer is the stage before it is executed. A buffer is just a signal. Even like when you are watching a live stream, there's always a buffer. You know, when you watch on YouTube like this video, there will be that gray mark that's keep on going ahead. That is called a buffer. It is simply loading it before you even reach there. Okay, that's why you have a smooth experience. Inkjet printers operate by having a printhead that moves. What does it move? It moves the nozzles side to side across the page. These spray droplets. Is there droplets? No, nope. Okay, it sprays liquid. Ink droplets. Yeah, okay, there you go. Onto the page. These ink droplets can be created using piezoelectric, or we have something called the thermal bubble. See, I don't even have to look at the options for this. It's so like direct. If a paper jam in the printer occurs, the printer stops and an interrupt is sent. Interrupt. Usually, I don't know why they like talking about paper jams as the most common interrupt signal. Like every time I hear interrupt, it's always printer jam, so on and so forth. So it's very popular. A printer is one example of an output device. Give 3. Okay, this is the most easiest question I've seen. So monitor, speaker, headphones. I'm just gonna give random. You can give yours. Keyboard, mouse, and a microphone. Okay, easy, very easy. Okay, go to the last page. Computer ethics are a concern for any users of the internet. Identify and describe 3 ethical issues. Now, ethical issues. Now, I think they would accept you giving stuff like hacking and stuff, but ethical issues involve related to the internet. So don't give other stuff like viruses and stuff like that. That is not from the internet. So if you're talking about the internet, you're talking about something like plagiarism. Okay, plagiarism is the copying of others' works. Okay, copying of others' work without permission. Okay, and you are claiming it. Okay, then we can mention hacking, because hacking is done under the internet. So that you just say unauthorized access to a computer. That's just the standard definition of hacking. You can then mention spyware. Spyware is one of the biggest internet ones. Spyware is use of third party to record key presses. Oops. to record key presses, and steal personal information. Okay, so that's it. That marks the end of this paper. I'm hoping you have understood the different concepts and apply them into various other papers. I'll try to do as many papers as I can. I've been saying that, but again, I've not been finding the time to do this, but hopefully this video has helped you with your understanding in terms of computer science. If you have any question, always comment down below. I'll try my best to answer it. And also I have my Instagram if you feel like messaging me there. So that marks the end of this video. Thank you guys for watching this. Do subscribe, hit the notification bell, and I shall see you in the next video. Goodbye.